So today we are going to solve this problem, longest mountain in array 845. So in this problem we have an array of numbers and we need to find the longest mountain inside it and return its length. Okay, so a mountain has 3 rows. Okay, and rule number 1 is at least 3 numbers. And rule number 2 is numbers go up first, and rule number 3 is numbers comes down after. Okay, let's understand clearly. So array is, so what is an array? An array is just a list of numbers like this. See, we have array 2 1 4 2 1 4 2 1 4 and 7 3 2 5. Okay, so every number has a position that's called index. So that position is 0 1 2 3 4 5 6. So index start from always 0. Okay, and now see, these numbers are height of grounds like 2 1 4 2 7 3 5. Okay, some place are high and some are low. So now what is mountain? See, so so the shape is look like this 1 4 7 3 2. Okay, so first going up then coming down, so this is a mountain. Okay, so this is a mountain. So now let's understand clearly. See, when you climb a higher mountain, like let's understand like this. So this is your home. Okay, and this is your school, CHOOL school. Okay, and so this is a mountain, so this is a top of mountain. Okay, so see, you go up from home, reach top, come down to school, so that is a mountain. Okay, so see, same thing in number also. Okay, 7 4 3 1 2. Numbers going up like 1 4 7, and numbers coming down, that was 7 3 2. Okay, so now let's understand clearly. See, 1 3 5 3 1. So is it getting bigger first? Okay, so 1 3 5, so getting bigger. Now is it getting smaller? 5 3 1. So okay, so how it's look like this? See, it's look like this 5 3 1. First it's getting bigger, then it's getting smaller 5 3 1. So it's a perfect mountain. Now let's take another example like 1 2 3. So is it getting bigger? 1 2 3. And is it getting smaller? No. See, nothing after 3, so never comes down. Okay, it's never come down, so it's look like this 1 2 3. Okay, so it's not a mountain. Now let's take another example 5 3 1. It is getting bigger 5, so already starting from big number, so never went up, so it's look like this 5. No, it's look like this 5 3 1. So it's also not a mountain. Okay, so see, 1 3 2 4 1. So it is getting bigger first 1 3. Okay, so 1 3 is getting bigger first. Yeah, so next 3 2 coming down, and 2 4 coming up again. Okay, so it's look like this 3 1 3 now 1 3 2. Next is 4 1. So 2 small hills, so not one mountain. Okay, so see, where is first mountain? See, in this mountain it's a perfect mountain, because see, up then down. Okay, and only up never comes. only up that never comes down. Okay, so see, only down never comes up. So in this up down up down up. Okay, so goes up again. So 1 3 2 4 1. Okay, now okay, see, so the problem is we need to find the longest mountain. So our idea is like, think like this. Imagine you are walking on this array. Okay, like value is 2 1, it was 1 4 7 3 2 5. Okay, so index 0 1 2 3 4 5 6. See, you are looking for the highest point, peak. Okay, highest point means peak. Okay, you are looking for peak, so of every mountain. So why peak first? See, because peak tell as mountain start from somewhere on my left and mountain end somewhere on my right. So if you find peak, okay, we can find the whole mountain. So let's understand like this. See, our first idea is we need to find the peak. Okay, we go to every numbers and ask, I bigger than my left, so I am bigger than my right. If both yes, so I am a peak. Okay, so it was clear. See, go to every number and ask if I come in this number. So okay, so I will ask, I am bigger than my left, so obviously 7 is bigger than 4, and I am bigger than my right. Yes, 7 is bigger than right, so it's a peak number. Okay, we need to go every number and ask this question. Okay, so if yes, so that is I am that peak. That was clear. So see, let's start. So stop, we see we started in index 0 and the value is 2. So is 2 is a peak. So we ask a question. So 2 is a peak, left side nothing there, so not a peak, so we move on. Okay, I comes here. So see, index 1 and value is 1, so 1 is a peak, left side is 2 bigger than 1, so not a peak, so we move on. So I comes here. Okay, next index 2 and value is 4, so 4 is a peak, 4 side 1 smaller and right side 7 bigger, so not a peak, we move on. Now we index 3 and value is 7. Okay, so 7 is a peak, small side is 4, so left side is 4 smaller and right side is 3, so smaller, so 7 is a peak. Okay, 7 is a peak number, so peak, now peak found. Okay, so now what we do, we go left from 7, so we start from index 3 7. See, 7 4, 4 is smaller than 7, yes, we keep going. Okay, so next is 4, 4 is small, is 1 is smaller than 4, yes, so we keep going. Okay, like for 1 and 1 1 1 and 2 now. So is 2 is smaller than 1, no, so we stop. So left boundary is equal to index 1, so we start from 1. Okay, 1 4 7. See, in here we got that 1 4 7, that's how we get these numbers. Okay, and now we go from right from 7. Okay, go right from 7. See, we start index 3, value is 7 7, next 3, so is 3 is smaller than 7, yes, so we keep going. And next 3, so 3 is, so see, is 2 is smaller than 3, here, so we keep going. Now 2, so 5 is smaller than 2, no, we stop. So right boundary start in, so right boundary is 5, so see what's become 7 3 2. So here how we get this number 7 3 2. We first find a peak and then we end with the boundaries. Okay, where it going to stop. Now we calculate the length. So see, left index is, so here we stop, so left index is 1 and right index is 5. So right index is 5, so how we find our length? Length is equal to 5 minus left, right minus left, plus 1 is equal to 5. So our mountain is 6. So the value, so the answer is 5. So see, index 1, 4, 7 and 3, 2. Okay, see, going up was 1, 4, 7, like 1, 4, 7, and peak number is 7. Okay, we're going up 1, 4, 7 and peak number is 7, and coming down was 3 and 2. So the number 5. Okay, so the answer is 5. So that's how we found our answer. So the answer is 5 only. See, okay, 1, 4, 7 and 7, 3, 2, which has length 5. So that's the answer. So now it was clear. So we go to next index also. See, now which index we have to go? Index 4 now. Okay, now we go index 4 and value is 3. So left side is 7. Okay, so bigger, so not a big, we move on. So I comes here. Now we go index 5 and value is 2. So left side is 3, bigger, not a big, so we move on. So I comes here. See, right side nothing is there, not a big, so we move on. Okay, so only one mountain has founded, that was 1, 4, 7, 3, 2. So the number is 5. Okay, so the answer is 5. Is that clear? Now let's take another example. Okay, now let's take another example, like we have values 0, 2, 3, 4, 5, 2, 1, 0. So the index is 0, 1, 2, 3, 4, 5, 6, 7. Okay, so the idea is walk through every numbers and find peak. Okay, so let's start walking from index 0. Value is 0. Okay, so let's start walking. So left side is nothing there, so it's not a peak, so we move on. So see, we are index 1 and value is 2. Okay, so the left side is 0, so it was smaller, and right side is 3, so it was bigger, so not a peak, we move on. So I comes here. Okay, it's not a peak, so we move on. So okay, now we are in index 2 and value is 3. So left side is 2, smaller, and right side is 4, so it was bigger, so it's not a peak, so we move on. I comes here. Now see, now index 3 and value is 4. So left side is 3, it was smaller, and right side is 5, so it was bigger, so it's not a peak, so we move on. I comes here. And now see, so index 4 value is 5. Okay, so left side is smaller, 4, and right side is smaller, that was 2. So the 5 is a peak. Okay, 5 is a peak, so peak has found. Now what, we go to left from 5. Okay, we go, now peak has founded, that was 5. Now we go to left from 5. Okay, so 5, 4, so is 4 is smaller than 5, yes, we keep going. Next 3, so is 3 is smaller than 4, yes, we keep going. 3. Next 2, so 2 is smaller than 3, yes, we keep going. Now 0, so 0 is smaller than 2, yes, we keep going. So 0 stop, nothing is there, so the boundary have set in from index 0. Okay, so we set the boundary, left boundary is index 0. Okay, now we go right from 5. Okay, so 2, so 2 is a smaller than 5, years, we keep going. Next is 1 is smaller than 2, years, we keep going. And is 0 is smaller than 1, yes, we keep going. 0. Okay, so 0 in there nothing, so we stop. So the right boundary is index 7. Okay, so now we calculate the length. So how left is equal to 0 and right is equal to 7, so length is equal to 7 minus 0 plus 1, it was 8. Okay, so 8. So the answer is 8. Now we keep walking. Okay, because the array is still there. So now we index 5. I comes here. So see, left side is 5, so not a peak, we move on. And I comes here. 1, so not a peak because left side is 2. So I comes here, right side nothing is there, so not a peak, we move on. So see, so the mountain A, our mountain is 0 2 3 4 5 2 1 0. Okay, so see, going up 0, we are going up from 0 ing, going up. Okay, so it was going up like 0 2 3 4. Okay, 5 is a peak, so 5 is a peak, and we coming down. Okay, we coming down 2 5 2 1 0. So numbers 8. Okay, so the answer is 8. 1 2 3 4 1 2 3 4 5 6 7 8. Okay, so the answer is 8, number 8. Okay, so only one mountain has found. Now let's write down the code. See, let's take that example. 2 1 4 7 3 2 5. Okay, index 0 1 2 3 4 5 6. See, first line we write in code, that was in n is equal to array dot size. Okay, so what is this doing? So see, so what this line is doing, we are creating see, we are counting how many numbers are in array. Okay, so the array is 2 1 4 7 3 2 5. So we count 1 1 2 1 2 3 4 5 6 7. Okay, so the n is equal to 7. So why do we need this? See, later we need to know we are at the end of the array, so we save the size first. Okay, next we write, see, next we write int one answer is 0. Okay, so what is this line doing? We are creating a box, like we are creating a box. Okay, so to save the answer, so why the answer is 0? Because box is empty right now. So why we have take 0? We have not found any mountain yet, so the answer is 0 right now. Later when we find mountain, we will update the box. Okay, we will update this box. Okay, now we have to traverse. So for it we write for int I is equal to 1 and I is greater than less than n minus 1 I plus plus. Okay, now see, so what this line doing, we are walking through every number in array. Okay, so we start from index 1. So why we start from index 1? Index 0 has no left side. Okay, so index 0 has no left side, and 2 nothing is left, so peak needs both sides, so we skip index 0. Peak was need both side, okay, left and right. So in index 0 there is no left, so that's why we are starting from index 1. That was clear. So see, we have stopped from n minus 1. Index 6 has no right side. Okay, so peaks need both sides, so we skip last index 2. Okay, that was clear. Now we write this. Next line is, if array of I is greater than array of I minus 1, is array of I is greater than I minus 1 and array of I is greater than array of I plus 1. So why we are writing this? See, we are checking, is this number, see, is this number a peak? So we asked two questions, and question 1 is, see, array of I is greater than array of I minus 1, so I am bigger than my left. So, and next question is, if array of I is greater than array of I plus 1, so I am bigger than my right, so both are yes, so I am a pig. Okay, so basically say first line is if we stand in this index, okay, in the index t and value is 7, so I will ask, so I am bigger than my left, so yes, 7 is bigger than from left. So next question is, I am bigger than my right, yes, obviously 7 is bigger than from right. Okay, so if both are yes, so that was I am a pig. Okay, now see, let's understand with the example. So let's take this example only. Index 3 value is 7, so array of I, say array of 3, that was 7, index 3 and I 7, so array of I minus 1, that was array of 2, 4, and array of I plus 1, that was array of 4, that was index 3. So the question 1 is, 7 is greater than 4, yes. 7 is greater than 3, yes, so both is yes, so the 7 is a pig. Okay, so 7 is a pig. So like example with index, let's take an example with index 2. Okay, value is 7. Okay, array of I, array of 2, that value is 4 and index is 2. Array of I minus 1, that was array of 1, and array of I plus 1, array of I plus 1, 3, that was 7. Okay, so the question 1 is 4 is greater than 1, obviously 4 is greater than 1, and the question 2 is, so 4 is greater than 7, no, it was no. Okay, so 4 is not a pig. That's how we find a pig. Okay, now next we need int left is equal to I and int right is equal to I. So see, if we found peak at index I, now let's understand like this. Just a minute. Okay, see, in left is I and right is I, so what is this doing? If we find peak at index I, so now we create 2 pointers. Okay, now we create a 2 pointers both starting from at peak. Okay, peak is at index 3, so the value is 7. So see, left is equal to 3 and right is equal to 3. Okay, now we move left, we will move right also. Okay, so we move both pointer, okay, left and right, that's why we take 2 pointers. Next we write while left is greater than 0 and array of left is greater than array of left minus 1, so left minus minus. Okay, so what we are doing here, see, we are walking from left. Now let's see here only. So we are walking left from peak, so we take 2 condition check. So condition 1 is, if left is greater than 0, so we are still inside array, and next condition is array of left is greater than array of left minus 1, so his next number is smaller, so both yes, we keep going left. Okay, so in that way left minus minus means move on 1 step left. So now let's see like this. We start from 3, so the value is 7, so step 1 is, see, left is greater than 0 means 3 is greater than 0, yes, and array of 0 and see, array of 3 is greater than array of 2, so 7 is greater than 4 obviously, so we move left, so left becomes 2. Now left is greater than 0, so array of 2 is greater than array of 1. Array of 1, like see, so 2 is greater than 0, yes. 2 is greater than 0, or 4 is greater than 1, yes. So we move left, so left becomes 1. Okay, so left is equal to, left is greater than 0, so array of 1 is greater than array of 0. So 1 is greater than 0 obviously, and 1 is greater than 2, no. So we stop here, so left is equal to 1, so left boundary is 1. Okay, left boundary is 1. So same we do for right also. Okay, same we do for right also. While right is greater than n minus 1 and array of right array of right plus 1. So same we are doing for right also. Okay, let's understand with example only. So see, we have two conditions. The first condition is right is less than n minus 1. We are still inside array, and the condition 2 is array of right is greater than array of right plus 1. So is next number is smaller, so both yes we keep going right. So that's why right plus means move one step right. Now right is 3, let's take right is 3, index 3, the value is 7. Right is 3, value is 7. Now step 1 is what we do is right is less than n minus 1, 3 is less than 6, yes, and array of 3 is greater than array of 4. So 7 is greater than 3, yes. So we move right, so like 3 become 4. Now 3 become 4. So next what we do, same condition is 4 is okay, 4 is greater less than 6 years, and 3 is greater than 2 years, so right become 5. Now 5 is less than 6 years. Now 2 is greater than 5, no, so right will stop. Okay, so the right boundary is 5. Okay, same. Now answer is equal to max answer right minus left plus 1. So see, we are calculating the length and saving bigger one. Okay, like let's understand this. So right minus left plus 1 means 5 minus 1 plus 1 is equal to 5. Okay, so the max answer is ns. Now answer is 0. We have done update 5, and so say max 0 comma 5, so the answer is 5. Okay, so why we take the max variable? Because there can be many mountains. Okay, we want the longest one, so we keep comparing. So is new mountain is longer than old one, so if that, as we save new length, if no we keep old length. Okay, in last we just return the answer, return ans. So that's it for C. We count numbers and we save answer. We walk through every numbers and we pick checking and start left from peak, right from peak. Next go left, next go right, return max, save longest, and in last we are going to return the answer. Yes. S. It's very easy. Okay, now let's try then one more example in the from this code. Let's clear all of these. Okay, let's take a small example. Let's take 1 3 5 3 1. Okay, so the index is 0 1 2 3 4. Okay, the first line is C, means int n is equal to array dot size, means is n is equal to 5. Okay, now n is equal to 5. Second line is what? Second line is answer. Okay, so the no we have not found any mount index, so the answer is 0. Next we walk through the array. Okay, let's try them from code. So I start from 1. Okay, we are starting from 1. So I stop at index n minus 1. So 5 minus 1, that was 4. So I will stop here. Okay, now we check. So okay, array of 1 value is 3. Okay, and array of 0 value is 1 left, and array of 2 value is 5. It was right. So 3 is greater than 1, yes, and 3 is greater than 5, no. So not a pick, so 3 is not a pick, so I comes here. Next, array of 2, that was 5, and array of 1, that was 3 left, and from right, array of 3, and it was 3, so it was right. So 5 is greater than 3, yes, and 5 is greater than 3, yes, so we found our peak. Okay, so it's a peak. Next we applied 2 pointer, left pointer and right pointer from peak. Okay, left is equal to 2 and right is equal to 2. Now we write index 1 3 5 3 1. So we find our peak here. Okay, left pointer and right pointer start from peak. Okay, to from here we start our pointers for these numbers. Now we go left. Okay, first we go left. Left is, let's put index 0 1 2 3 4. Left is greater than 0, 1 is greater than 0, yeah. So array of 1 is greater than array of 0, 3 is greater than 1, yeah. So we move left. Okay, so left is greater than 0, so 0 is greater than 0, no, so we stop. So the left is equal to 0. Okay, so the left stop comes here, stops here. Okay, now we go right. Okay, we go right. So the right is greater than n minus 1, 2 is greater than 4, yes, and array of 2 is less than, okay, sorry, less than, so 2 is less than 4, yes, and array of 2 is greater than array of 3. So 5 is greater than 3, yes, so we move right. So right become 3, right is equal to 3, and right is greater than n minus 1, 3 is less than 4, sorry, less than, okay, less than. And next, array of 3 is greater than array of 4, yes, 3 is greater than 1, and we move left, so it becomes 4. Now right is less than n minus 1, 4 is less than 4, no, so we stop here. So right is stop at index 4. Okay, and the value is 1. So now we calculate the length. So left is 0 and right is 4. Left is 0, right is 4. 4 minus 0 plus 1, it was 5. So the max 0 comma 5, so the max is 5, so the answer is 5. That's it. We check this index also. Okay, we come here also. Okay, let's try on full. Index 3 and value is 3, so array of 3 is 3 and array of 2 is 5, left and array of 4 it was 1, right? So 3 is greater than 5, no, so not a pick, we skip. So we going to return 5. Okay, answer is 5. Now see, we are going up 1 3 5, so going up. Okay, G-Y-N-G, going up. And it's a pick, 5 is a pick. Okay, now we are coming down 3 1, so we are coming down. Okay, 1 2 3 4 5, so the answer is 5. It was clear. So see, we visit every number once, so array has n numbers. Okay, we do n steps. So example, let's take this example. 1 3 5 2 3 2. Let me write in clean way. 1 3 5 3 1. So 5 numbers, 5 steps, so that is big of n. So see, why it was not big of n square? Every number is visited we see it only once, so left pointer only move left and right pointer move only right, so they never go back, so total steps is n. Okay, and the space complexity is we only create n and answer I left right, so one box, one box, one box, one box, one box, 1 2 3 4 5. Okay, so just 5 boxes we have created. Now see, no matter how big array is, always only 5 boxes. Okay, so that is big of 1. So the time complexity is big of n, we visit every each number once, and the space complexity is big of 1, we only use 5 variables. Okay, that's it.